Hello, in this video, we will look at minimizing numerical errors. Using floating point numbers in the loop continuation condition may cause numerical errors. So let's look at this program here. We have this is the sum of all the numbers from 0.01 at all 0.02, 0.03, and this 0.99, and then 1.0 add all together into sum. So this is I is less than or equal to 1.0. Now, looks like this program is correct, but when you run the program, you end up with 49.5. And now look, the correct answer should be 50.5. So that's a big difference. You lose one. What went wrong? For each iteration in the loop, I is incremented by 0.01. When the loop ends, the I value is slightly larger than 1.0, so that you just missed adding 1 to the result. So if you look at this last one here, I'm going to want to see what is the last one here. Now you can print this last one here. The last I is, so you can see that this is the last I is, and this is the last I. So last I is this number, just a little bit over 1.0. So you can see it's a big difference. So when you write a program, so pay attention to this kind of situation when you have the condition involving comparing the floating point values. So what I'm going to do now is to rewrite the code using, instead of using this floating point numbers in this condition, I'm going to use a count. So I'm going to have this count here, or use this for loop for this count in range 0 to 100. So this is going to be performed 100 times. So every time I'm going to have this I is now incremented by 0.01. So this is my sum. I'm going to add I to sum. Let's run this program. Now you're going to see this is the result, 50.5. That is all for this section, minimizing numerical errors. Thank you for watching. See you on the next video.